Hey folks, I'm just leaving the office. We're going to go to ExperiencedDevs for the topic today. And I thought this one was pretty interesting. This question sounds kind of funny on the surface, but I peeked through the comments and I was surprised to see that people weren't just totally like bashing it, but kind of like also chiming in with real examples. So the question was really like, what sorts of things have you worked on in your career, right? What types of projects and stuff have you worked on where the tolerance for bugs is very low, right? And then the reason this sounds kind of funny is like, well, we're building software, the tolerance should have very low tolerance for bugs. But there was this acknowledgement that like there's some types of things that people build where you can absolutely be more tolerant to that. And I thought this would be a kind of a fun one to talk through because I think that in reality, like we can kind of say like in theory we don't want to have any bugs, we go through all these things, but like in practice it's almost not what happens. So I figured I'd share some background for some spaces I've worked in where the tolerance for bugs was very low, but I can also talk about like where there was, I don't want to say like, it sounds funny to say like there was tolerance, because what I don't mean to suggest is like we didn't give a shit. Like that's not, and I want to be transparent about that the whole way through, is at no point am I going, oh, like we never cared, therefore we just like wrote buggy software. Like it's probably gonna sound like that as I'm talking, but it's never what I mean. It's just that like there was more rigor around like the other areas. So just want to get that out of the way, disclaimer. But so for me, it was digital forensic software. And the reason, like, let me kind of explain some of the background as to why, and then kind of like how some of these pieces work. So the reason why that this stuff is super critical is because a lot of the time, like one of the really key parts of a digital forensic software is being able to structure otherwise unstructured data. And so what does that mean? Well, okay, so something that would be very simple for digital forensic software to do is to like look across, a file folder hierarchy and get you all of the documents, right? Find me all the files that end in DOC or DOCX or PDF, right? Like that's a pretty like low hanging fruit kind of approach to like getting you documents. But like, what about documents that have been deleted, right? So like in digital forensics tooling, we need to be able to, as much as like recover as much information as possible and structure it. Now that means that oftentimes you're dealing with stuff that is not necessarily in an easy accessible format. It might not be something that's like just open the file, because you're literally taking pieces of file segments from a hard drive. Oh my God, come on, people. So it's not just as simple as like open the file on the within a folder kind of thing. Sorry, trying to get on the highway and no one was moving over, and then we had people that were going too slow to merge onto the highway, not helping. So when you have data that's like this, you're a lot of the time, and I don't want to say the majority of the time because it's not really fair, there's a lot of files that are intact on a machine, but there's going to be a lot of situations where you're going through parts of hard disks or within like archives of different files, like whatever it happens to be, you're dealing with data that is not guaranteed to be structured perfectly for you. Now, when we go to restructure that data, there's going to be opportunity to mess things up. But what we need to be very clear about, and this is where there's a very low tolerance for bugs, is what we're reporting when we structure that data. So things like timestamps and things like that, we need to be extremely clear and accurate with a timestamp. Why? Because if that's being used in a court of law, and we have, like, there's evidence that comes from our tool that's used in a court of law to either try and prove someone guilty or help prove someone's innocence, if we are wrong with the timestamps, that could tell a dramatically different story. Okay, so it's really about trying to make sure, like, I can't remember, at some point, like, the saying for the company was, like, bring the truth to light, right? I can't remember what the exact mission statement was, but, like, like, we had it on the walls and stuff, like, about uncovering the truth, because that's the whole goal with the software, is to make sure that, oh, come on, buddy, you're gonna cause an accident, holy fuck. I don't know if you could see that. Mercedes actually locked the seatbelt on me. Ugh. Absolute dumbest people drive around here. I cannot believe it. This person's lined up in traffic. The guy in front of me almost hit the person, and then he tried to pull out again. Like, if you're not driving at a normal speed, you cannot pull out in front of traffic. That's the first one we got on video, I think, on this channel. So, what was I even saying? We're talking about, uncovering the truth, right? So, things like timestamps, we need to be extremely accurate with. Because if we misrepresent that, not only are we not doing, like, what we set out to do, but, like, you could literally have the opposite effect. Because now the story that the data is telling is no longer the true story. Another problem is that if that is shown to be inaccurate, right, and then you erode the trust in the tool, how can they trust the rest of the data that you're showing? You have bugs in your software. How do we trust the data that you're showing? Right? So that becomes really problematic. Not only, like, it looks terrible in court, they could toss it out, but, even worse would be if it was wrong and they used it. Like, that's not okay. So for us, that kind of thing was really important. Give me 1 sec, because I got to switch lanes. Just want to make sure I was going fast out by this huge F-150. And then another thing, just to kind of comment on it too, is, like, sometimes the data that we're recovering is not as obvious as one might think, right? There was I'm trying to think. I can't remember the specifics of it, but my wife was watching this Karen Reed trial. She loves watching court TV. And, like, the streamer, like the lawyer streamers who talk through court. And it was cool because she was watching this Karen Reed trial, and they were talking about the software that I helped build. So it was super cool. And then they even had an expert witness come on that I used to work with. And I was like, there's Jessica Hyde. Like, I know Jessica. Like, super cool. So I could kind of nerd out a little bit, because my wife, like, rightfully so, is not super interested in the work that I do, because it's pretty nerdy and she has better things to care about. But she was really interested in court, so when they were talking about the digital evidence, she could ask me questions and I could explain to her from, like, the software side, like, what goes into that. So anyway, there was part of this trial where they were talking about some of the recovered evidence. And like I was saying a little bit earlier, we want to be able to recover as much data as possible and present as much data as possible. But not all of it is in a state where you can, it's going to sound kind of weird, but, like, it's not, like, always easily explainable. So, for example, you might come across timestamps, okay, in the data that you're recovering, and you're like, the timestamps are, like, you want, as much as possible, you want to be able to get back timestamps, because timestamps can really help paint a picture of the activity that's happening. The tricky part is, like, when we think about forensics and recovering data, it's not like, for the most part, it's not like people are building applications or file formats and stuff where they're like, I'm going to write this so that someone can use it for digital forensics. They're writing it because they're software developers who are like, I got to store this date time because that's what I'm going to use for caching or something else. Like, it's not meant for forensic record. It's meant for literally supporting functionality of the application. Now, what happens is that when we're trying to recover data, we come across a timestamp and we're like, oh shit, we better include that because it's going to be useful. And someone goes, well, what does it mean? And sometimes it's like, well, that's clearly the last write time or the last modified time or something, right? There's some really obvious things. The message was sent at this point. Well, wait, is that when the message was sent, or is that when the message was actually like received on the device? Is that when the message is read? Like, all of a sudden, these things become more nuanced. And there was this thing in this Karen Reed trial, and sorry if I butcher this because, like, I wasn't really paying attention. My wife really was. But there was this data that was recovered where they were talking about the timestamp for these, like, browser tab activity. And they were trying to figure out, was this the time that the search was performed? Was this the time that the tab was activated? Was this the time the tab went into the background? Like, there was a timestamp and it wasn't clear exactly what it was. But they were trying to say or disprove that this is the time that a search occurred. Now, when you label it something, if that's not accurate, that's a problem, right? So it's extremely important to have the fidelity of the data preserved as much as possible, right? You're not taking timestamps and rounding them to the nearest day, and you're not calling things what they're not. You have to be very explicit and transparent about what that data is. Furthermore, you can like kind of go through this exercise and talk about different types of data and understand why it's really important. There's like in digital forensics, historically, investigators and examiners are obsessed with hashing things. Absolutely obsessed with it. Cryptographic hash on something, because if a bit changes, then they can go, oh, like, we're no longer talking about the same data. Like, over the top, obsessed with it. And like, part of me gets it, and the other part of me is like, at some point, like, this is getting silly. Like, I'd see people hashing things where I'm like, you've already proven it's the same thing, like, through two other mechanisms. Why are you hashing it yet again? Just like, seemingly completely nonsense, but I get the motivation behind it. So they're obsessed with that kind of stuff, which is a good reminder, like, for you understanding your customer as a developer, like, that's how much they care about the accuracy of this stuff. There's one more thing I wanted to talk about on that, and I'm forgetting it. It'll come back to me. But data accuracy, incredibly important. Oh, this is what it was. So if you keep going through this exercise of like talking about the different types of data that get recovered, like, essentially it's a big search engine, right? It's a search engine for digital devices. So that means that when we run a search, if you were to do that search again, you should expect the exact same set of data to come back. And if you did it again, you should expect the exact same set of data to come back. Now that means if you're making updates to the software and you rerun the same search, you should get the exact same set of data to come back. Or more data. Right? You've made updates to it. You better not be missing stuff. It better be more data or the same. The exception to that is if you are fixing bugs and correcting things, right? So the accuracy in terms of being able to, go from one version to the next and make sure that you're not regressing on these things is critical, because it goes back to, like, Okay, so like between one version and the next, now we're missing the timestamps. Now we're missing the records that had those timestamps. Like, oh shit, isn't that a big problem? Because now that's no longer showing data that we know is there. So being like bug-free in that regard was absolutely critical for us. Zero tolerance, right? Like, just not okay. Now, where were we more tolerant? Again, the disclaimer is not like, oh, we just don't care, we'll go build crappy software. But it was the difference between, do we need to go stay up all night so we can hotfix this, versus like, the release goes out in 2 weeks, like we can put the fix in and it'll be ready for the 2 weeks when we're going to go release this. Okay. The difference where it was more, we were more lenient when we caught bugs like that was really around like workflows of things that weren't blocking. Right? So if you were interacting with the user interface and you pressed a button and it caused some weird state to happen, but you could still perform the action you needed, it was just like kind of glitchy, or we have 2 or 3 paths to do the same thing for whatever reason, same type of thing that you're trying to accomplish in the end. One of those stopped working and you can't click through, but you can go through the other paths. Like we're potentially not going to go hotfix that. It's not like we want to ignore it. We're going to go fix it, but we're not going to go like rush. We're not going to stop everything we're doing to go fix that. So we had to go ask ourselves these questions of like, is this going to block someone from being able to perform their examination or investigation on this data? And if it's not, or it's not going to put them in a state where they're going to misrepresent this data, then we can perhaps be more lenient to that. So same suite of software we're talking about, but that's something to consider. Certainly regressions were the biggest things. So I'll give you another kind of angle on this. One of the teams I managed was responsible for doing mobile acquisitions. So I was just describing to you kind of how we would scan through data and sort of structure it, right? So we're looking for data that's either there or it's deleted, and we're recovering it so that we need to go from unstructured to structured data. The team that I was responsible for, one of the teams for many years, was responsible for doing mobile acquisition. So you would connect a mobile device, and then we would go, as best we can, go collect all of the data that we can from that. It's not doing the other part that I just said, like the search engine, but it's basically trying to make as high fidelity of a copy of that device as possible. So, of course, in a perfect world, that means a byte for byte exact copy of the device, right? If it's a byte for byte exact copy of the device, you literally have a perfect replica of it. Excellent. It's not easy to do. And we were always looking for ways and new techniques to be able to do that, because that is the ultimate best case scenario. But a lot of the times with mobile devices, you're not able to do that. There's limitations, especially with the hardware. So you would fall back to like, well, what's the highest, we call it like a logical acquisition versus what I was just describing as a physical acquisition. So you would default back to like, well, what's the best logical acquisition we can do to get as much information back off the device so that when we go to search it, we can get as much information as possible. So where am I going with this in terms of like bug tolerance? Well, mobile phones are tricky because there's a shit ton of them. There are so many device models. It is absolutely insane. And we were a small team, like a handful of people, okay? And I can remember when we were like literally trying to research different devices and recovery techniques and stuff. There was times where like, we're a small company, right? Like times we go to the mall and it's like, I gotta go spend $5,000 on phones. And like some of the kiosks literally would not allow us to buy phones. They're like, no, we're not selling that to you. Or like, we want to go buy like $3,000 worth of phones from you. And they're, nope, won't do it. And I'm assuming in hindsight, I think that's because they thought that we might be like criminals trying to like do malicious things with phones, so they won't sell us devices. Like, we're coming with stolen credit cards trying to buy a bunch of phones or something, but we're like literally doing the opposite. We're trying to support police officers. So with all these devices and stuff, and the ways that we're trying to be able to recover data from these devices is like, there's a lot of cutting edge stuff and a lot of surface area that we physically, like, it's impossible for us to cover, right? So for example, we might be trying to use a mechanism that allows us to do certain things on Samsung devices. But how many Samsung devices are there? There's tons of just Samsung devices, or Qualcomm chipsets, or, you know, HTC phones or Sony phones. Like, there's the matrix of all of these combinations of things is nuts. And there would be some times where if we're looking at this matrix, we're like, hey, there's a technique that we might be able to use to be able to go get a good acquisition of this type of device. But we're still not going to be realistically able to go buy all of those devices. It would be nuts. You know, one of every model kind of thing. We can't do that. It's not scalable. So what would we do? Well, we would go do our best, right? We would get some devices to go work on, make sure that we can have this thing in place, and then we would basically open it up as like an experimental new feature. And we would have all of this telemetry in place to let us know what types of devices people are putting through those workflows. And what would happen is we could measure the success rates of those things and see, this new experimental feature that we've turned on, like, it's working really well for like A, B, and C, but like if we go back to our matrix for like D, E, and F, it's actually terrible. So we go, great, okay, like we can narrow this down, and then we might need to go buy more devices in these other categories to go do further research. But this is because it was a new feature, and what we could do is basically when it wasn't working, it would fail. It's not a regression. It was never it never worked in the first place. So we're basically just potentially opening up new doors for people, and that's something where we could be more like tolerant to a bug, right? We're saying it's supposed to work across this group of devices. If it doesn't, it's not the end of the world. It's not like we gave them something and lied about it and said like, oh, here's data from the device, and it's totally not. It would just end up not supporting the device, and they could go try another mechanism that we have. So my point here is that for these scenarios, it didn't have to be perfect. And that was something that actually allowed us to have a ton of agility in developing. We could do a best effort thing for these new approaches, pack it with telemetry, and then we would go monitor the telemetry. So we could see all the times where like it's failing on things it should be passing on. We could see, sometimes we'd see like, hey, they're using devices through this path, and we didn't even think that they would work. But now we have concrete evidence that that's happening. Or like any combination of this that you can imagine, and that let us build confidence or understand where to go invest into. So just an example of something where we could be more tolerant to bugs or being imperfect, but we actually use that data as a feedback loop. Reflecting on that was like one of the most, it sounds kind of silly, but like one of the most powerful things we had on that team going for us was our ability to be like truly agile in that way. Given that we had a really good data feedback loop, we could iterate super fast. Oh man, sorry, there's metal on the road, and I made sure I drove around it, but I was pretty nervous. Like sharp metal. We could use data very like effectively and iterate very fast. So you know, for us, we didn't continuously ship, but like we had continuous builds, right? Like if you pushed up, it was a really cool thing for our team, and like there's many teams that are like this, especially in web development, but we're desktop software, and you know, the other teams in the company are doing monthly releases, and they have to do all this work to gear up for their monthly release. And for us, it was like, you could, if you wanted to, you could take any of the builds, and this is how it should be, right? Like, if someone was like, we want to do a release tomorrow, great, just take the build. Well, what if you like, don't you need time to prepare? Like, no, if it's built, it's ready. It's done. There's no more. We have 100% confidence in whatever comes out of that build system. Take it. Every time. That's how that product was built from the beginning. So we can't really say that about some of the other ones. So they had more things that had to go in place, which is fine. But for us, that's how it went. And that meant that if we wanted to hotfix something, or we wanted to, they had a one-off release, we could, any point we wanted, we could have this feature where we're like, oh shit, this is the coolest thing. We don't want to wait a month to go release. We want to release it right now. We could just go upload the build. It's ready. And then if marketing wanted to do anything around that, then they could. So it was really cool for desktop software. We got to be super agile that way. I'm not using agile to talk about, the development process, just literally agility. And that came with telemetry as well. So yeah, I feel like without the telemetry, it would not have worked. With the fact is that we could release very rapidly, which is good, but we had visibility. For a little bit of extra context too, like, you might be saying, well, dude, there's like obviously telemetry and all this software, like, no shit. But little bit of background, especially in digital forensics, some people literally have their forensic workstations not connected to a network. So telemetry don't make sense a lot of the time. But there was this notion that people would be so adverse to telemetry that there would be no point ever putting telemetry into a product. In fact, it would scare people away. Right? This is forensic software. You're putting telemetry in here? Like, get out of here. Like, absolutely not. And we actually used this product to prove that wasn't the case. We were very transparent about what we would send back, just like usage statistics about like what we're doing so that we can improve the product. Never sending back actual data that's being like examined or extracted or searched or anything like that. Just like operational information so that we can debug better. So had a lot of disclaimers and stuff like that, and it was opt-in. And another sort of thing that we had was automatic updates, and that's one of the best pieces of telemetry, because we were told, industry standard is all these things aren't on the internet, no chance. Well, if that's the case, then having, automatic updates makes literally no sense at all, right? And they were like, oh, interesting. How many updates are happening, or how many downloads do we get off the website versus automatic updates through the app? Yeah, there's a lot more people with automatic updates on. This light's broken. Damn it. Come on, man. It's already gone through twice. This bozo's got to back up. And the guy behind him's got to move forward. So dumb. Anyway, yeah, we use telemetry a lot, and kind of pioneered that for our company to be able to say, like, hey, look, if we use telemetry, we can actually, like, I've told this on Code Commute before, but we use telemetry so effectively, even with like error reporting, that really awesome guy we had in tech support. I remember when we hired him, in my career, one of the best hires for a role ever. And he's so good at talking with customers. Like, he can get the technical stuff, not a developer, get the technical stuff, can work with people that are pissed off about things and just navigate. I don't know how he has the patience for it. He's amazing at it. And so we would work with him, and it got to the point where like we could tell him about that we fixed issues before customers even reported them, because we could see it in telemetry. And because we could build that fast, this guy's running out to press the button, nice. Because we could build and release fast, if a customer needed a hotfix build or something, we could just say, like, it's on the portal, go give it to them. But yeah, overall, I'm going to wrap this up just because I'm waiting at this light and I don't want to keep rambling, but kind of an interesting reflection, I thought, to be able to think about different, same set of software, same suite of software, and these different scenarios where truly no tolerance for any bugs at all, and some situations where it's not that we're just like willing to have bugs, but if they come up, we're not staying up all night to go hotfix them. Different scenarios, and that's kind of neat. So anyway, if you have questions about software engineering or career advice, leave them below in the comments, or go to codecommute.com and you can check out my other channels where I got other software engineering stuff. So DevLeader is my main channel with programming tutorials and C# or AI tooling. And then I have the DevLeader podcast where you can check out conversations where I interview other software engineers, and a live stream every Monday at 7 p.m. Pacific. And then there's DevLeader Path to Tech, where I do resume reviews, and I'll put together some other videos on transitioning into software developer roles. So thank you so much for watching, and I will see you next time.